So I'm Claudio Augugliaro, and I'm based in Mongolia since 2013. They're getting old. And study about snow leopard since 2015. Snow leopard became the topic of my PhD at the University of Lausanne. And so I spent quite a lot in the last 10 years by studying the species across Mongolia with a different number of partners. And until I founded the Wildlife Initiative, which is an NGO which has a branch in Mongolia, Italy, the Democratic Republic of Congo, and Namibia, and working also in Central America, where the carnivores are the main topic of this of our study. So since that time, Marcello joined us, and other people. The team became a little more international and wider. And before I founded the Wildlife Initiative, in partnership with the Institute of Biology of the National University of Mongolia, we set the study that Marcello will describe better later, in the Great Gobi A. It was now we have all the approach for multi-season, multi-years project. In that time, in a single season sampling, was first time I did a sampling for snow leopard in the deep winter. Also for me, quite shocking. Even I used to stay in Mongolia already for many years, but going the field from December to February was very hard. And I remember sampling at -25, zipping the car in -30. Because in the Great Gobi A, strictly protected area, basically there is no logistic, there is no herders, basically, except in the customs, there is a military, and then a couple of herders living around, but in that time was not anyone. So we slept in the tent, in the car, and -30 was quite hard. And we did that sampling, that was obviously a great experience in 50,000 square kilometer uninhabited by human. Was really, really wonderful. And later, with the help of our Mongolian colleague, collecting that in the field, and later with the help of Marcello, Sandro, the professor, hello, and then Luciano Zeni, we start analyzing and writing a first draft of this work. Then now Marcello will introduce. So it's time to leave Marcello explain what we did. So Marcello, it's your turn. Bye.
Okay. Well, as a first, good morning to everyone. Thank you, Claudio, for the introduction. And as he said, my name is Marcello. I'm an associate of Wildlife Initiative since 2020. So basically since the year in which the NGO was born. And beyond that, I'm also a postdoc researcher at the University of Udine in the northeast of Italy. And my main research activities revolve around the human-carnivore conflict and coexistence, but I'm also really keen about large carnivores' behavior and ecology. And today, as Claudio said, I'm here to present the results of our study that we published in 2023 regarding the spatial temporal behavior of predators and prey in the Great Gobi A. The data were collected in collaboration with the Department of Biology of the National University of Mongolia. And well, now I will show you what we find out during our data collection and analysis. So I would like to start first by introducing some ecological concepts in order to give a clear vision about the state of the art. And as a first, I would like to talk about the concept of niche partitioning, which is basically an ecological process based on which terrestrial mammals tended to adapt their spatio-temporal behavior in order to avoid the risk of negative interaction with other sympathetic species. This concept is particularly suited for carnivore species, especially carnivores of different sizes. And because in this concept, typically carnivore of smaller size tend to adapt their spatio-temporal behavior to avoid the direct encounter with top carnivores, and in order to avoid the risk of being killed. In fact, interspecific killing exerted by top carnivore on smaller one is typically adopted for several reasons. As a first, for feeding purposes in certain circumstances, also to reduce the risk of mortality for their offspring, and also to indirectly reduce the risk of interspecific competition, and in turn increasing the accessibility to resources. However, the presence of top carnivore species is not always a trade-off for smaller carnivores, as in line with the facilitation hypothesis, smaller carnivores and mesocarnivores especially may take advantage of the carcasses left by larger predators for scavenging opportunities. This behavior was already observed, for example, concerning the red fox in response to the presence of both the snow leopard and the gray wolf. However, this represents, as reported in this study conducted in 2022, represent a high-risk, high-gain strategy, because if mesocarnivores are detected during scavenging by the top predator, they may incur into the risk of being killed. Conversely, prey will adopt a different response, so they will shape their pattern of activity and behavior in order to reduce the likelihood of encounters with top predators in order to avoid the risk of fall prey of them. But likewise, according to the harm race hypothesis, also predator will tend to shape their pattern of activities in order to maximize the probability of encounters with prey. In line with this concept, so this hypothesis, prey, to maintain this system stable, must be at least one step ahead compared to predators, because their risk is considerably higher compared to predator, because the cost of a mistake corresponds to a death, as they typically compete to survive. For what concerns the Mongolian Gobi Desert, this area is extremely interesting and hosts a unique mammal community, which was only recently described, which is adapted to live in these difficult conditions. However, the ways in which the species that live in this area are still so far poorly described. There are few works that were realized so far. One of these was realized in 2021 by Nasambat et al. In the Mongolian Gobi Desert. And the aim of the work through camera trapping was to explore the spatial, temporal, and seasonal use of water holes present in the area, which is a fundamental resource in this arid environment. So to achieve their goal, they placed basically 38 camera traps in the near proximity of 6 water holes. And basically from 5 up to 8 cameras were placed along each water hole at a distance of 60 to 120 meters, more or less, depending on site accessibility. And the sampling period covered 2 years. So cameras were active from May 2015 up to May 2017. And the findings obtained were interesting, as they revealed some complex spatio-temporal interaction between the 10 mammalian species that were observed through their camera trapping behavior. And especially they observed that water holes were used differently among these species, depending on the site, the season, and the time of the day, thus allowing the coexistence between these communities, and especially between predator and prey in this arid environment. Another interesting study was recently published in 2024, and the aim of the study was instead to explore, based on the concept of the intragill predation, with the aim to explore how the presence of a dominant predator, a dominant carnivore, may significantly or not affect the site use of a smaller one, and in this case they used as target species the snow leopard and Eurasian lynx. Again, they used camera traps in order to achieve their goal, and from 2017 to 2022, so basically in a span of 5 years, they placed 142 camera traps across 6 different sites, including the Great Gobi A strictly protected area and the Small Gobi A. And the sampling design was focused to assess the snow leopard abundance, so cameras were placed in habitat typically frequented by this animal, and along trails used by the field or in the near proximity of marking points in order to increase the probability of detection. Again, the results showed that indeed the presence or absence of the snow leopard significantly affected the site used by the resident lynx. And specifically, in the absence of the snow leopard, it was shown that lynx used rugged terrain according to their availability, while they tended to avoid shrubby areas. Conversely, in the presence of the snow leopard, lynx avoided rugged terrain, which are habitats that are typically used by the snow leopard, even if the authors in their work, they did not find a significant relationship between the snow leopard and the presence of rugged terrain, and had a strong preference for the shrubby areas. In this case, the selection of shrubby areas may be linked to dual facts, basically. From one side, they may be used as refuges in order to avoid to be detected by the dominant predator. And from the other side, they may also have been used in order to conceal their prey and to avoid the risk of kleptoparasitism behavior. So basically, coming to the aims and hypotheses of our work, through camera trapping, our aim was to basically increase the still poor amount of knowledge about the spatio-temporal relation between carnivore and prey communities in the Gobi Desert. And in line with the facilitation hypothesis, we would have expected to observe some positive association between the spatial and temporal behaviors of the mesocarnivore in relation to the presence of a dominant predator. While in line with the avoidance hypothesis, we would instead have expected to observe a negative association. So we basically would expect to observe that prey will tend to adapt the spatio-temporal behavior in order to avoid direct encounter with the dominant predator present in the area. The study area, as I said before, was concentrated in the Great Gobi A strictly protected area, an area that covers about 50,000 square kilometers, characterized by an arid climate with few precipitation that are mostly concentrated between July and August, and few snowfall during winter as well. The area is protected since 1975, given to the presence of some threatened species, such as the vulnerable snow leopard, of course, but also the critically endangered Gobi bear and Panthera camel, both showing in reality also the snow leopard declining population trend. For what concerns the sampling design, well, the sampling period as a first was concentrated between December 2018 and February 2019, so basically during the winter season. And the sampling design was specifically tailored for carnivores and specifically for the snow leopard. So according to this sampling design, 94 camera traps were placed along 47 sites. So 2 cameras were placed at each site along narrow passages and few ridges because we did not detect clear signs of presence of the snow leopard in the area. So we did not basically identify marking points. And the distance between cameras was taken of approximately 3 kilometers in order to guarantee the independence of each side. Cameras were basically placed from the mountain foothills to higher elevation, while instead the valley bottom was not monitored. So cameras were not placed there because in these cases, trails used by these species were hardly detectable. So the placement of cameras may have been difficult in that circumstances. To explore the abundance of each species using camera trap data, we used the relative abundance index, which is a common index used for these kind of studies. And following the work realized by Meek and colleagues in 2014, in order to determine the independent detection events, we used an interval of 30 minutes between pictures of the same species at a given site. This is a table of all the species that we have detected during our activity. However, in order to encourage the maximum likelihood estimate of parameter, we decided to concentrate our analysis only on those species for which at least 10 independent detection events were obtained, while we excluded all the other species, such as, for example, among the carnivores, the Eurasian lynx and the gray wolf and the Pallas cat, because of the low number of detection, and the same situation was for prey. So we decided to exclude also the few detections we obtained for the Bactrian camel, for example, and the greater gazelle. In line with the facilitation hypothesis, so to explore if to assess if our hypothesis was met or not, we decided to use a single season multi-species occupancy and few occurrence models, as well as conditional occupancy model, as I said, to explore if the spatio-temporal relationship between the snow leopard and red fox was significantly associated or not. And additionally, we used also the kernel density estimates in order to explore the temporal relationship between the red fox and the snow leopard. In the multi-species, so basically, I forgot to say that in the occupancy model, we decided voluntarily to exclude the prey in the analysis because, because of the low number of detection, as I said before, but also because prey compared to carnivores tend to use preys less frequently. So in some way, this may have biased the results achieved. However, in the occupancy analysis, we also included some topographic covariates in order to explore their effect on the predicted snow leopard detection and occupancy probability. And we also formulate some rationale. Among these topographic covariates, we decided to include the topographic richness index, which basically indicates the amount of elevation difference between adjacent cells of a digital elevation model, the elevation, the density of riverine areas, and also the compound topographic index, which basically represents a measure of the soil moisture. For what concerns the richness and elevation, we would have expected to observe a neutral effect in terms of snow leopard detection and occupancy, because despite this habitat are frequently described as fundamental to indicate the habitat used by the snow leopard. In our study area, for the reason explained earlier, we placed a camera at elevation spanning from 1,500 meters, more or less, up to slightly more than 2,000 meters. And additionally, the terrain richness in our study area was still mostly homogeneous in order to produce a significant effect. So basically, this was our initial hypothesis. Conversely, we would have expected to observe a positive association regarding the snow leopard detection and occupancy in response to the density of riverine areas and the compound topographic index, because given that in the Great Gobi water is scarce, the presence of water indeed represents a fundamental resource that should allow the species to survive in this extremely harsh environment. Conversely, we formulate also a specific rationale also for what concerns the predictive influence of these covariates on the probability of detection and occupancy for the red fox. For what concerns the terrain richness, we would have expected to observe a neutral effect, and as well for the elevation. First, because terrain richness is, well, rugged terrain are frequently used by the red fox as refuge areas in those cases of intense human hunting. But because the Great Gobi is a protected area, the hunting is forbidden, so we would not have expected to observe a significant association. And for the elevation, higher elevation, based on the literature available, has generally a negative effect on the red fox habitat use. But in our case, because the sampling area was covered the mountain foothills to higher elevation and the snowfall are limited in the area, which is typically the key aspect that limits the habitat use of red fox at higher elevation in certain environments. we would not have expected to observe a significant association. For what concerns the density of riverine areas and the compound topographic index, again, we would have expected to observe a positive association because beyond the presence of water, which, as I said before, is extremely important in this environment, riverine areas are typically used also as ecological corridor by other species, and especially by the Tolai hare, which is a typically prey of the red fox. Again, the kernel density estimate was used beyond that to explore the temporal relationship between the snow leopard and the presence of its potential prey, so namely the Siberian ibex, the argali sheep, the Asian wild ass, and the Tolai hare. So we would have expected to observe that these species would have modulated their temporal behavior to avoid direct encounter with the snow leopard. Here we can see the table of the results in terms of detection events, which is basically the same table I showed you before. And as you can see, the red fox was the carnivore that showed the species, broadly speaking, that showed the higher number of detections. So this result further highlights the ecological plasticity of these species, which enable the scanning to colonize a wide spectrum of habitat. Conversely, among the prey, the Tolai hare was the most frequently detected species. The low number of detection obtained in relation to the other carnivore species, so basically the wolf, the Eurasian lynx, and the Pallas cat, may be linked, well, maybe from one side to the low density in the area, at least at those elevations, but also to the fact that, as I said before, the sampling design was specifically tailored for the snow leopard. So this in some way may have influenced the results achieved. And for what concerns prey, we will not surprise it to see a lower number of independent detection regarding the Bactrian camel and the greater gazelle, which, as reported in other studies, these are not mountain-dwelling species. Despite we observed a positive effect, a significant positive effect of density of riverine areas and topographic readiness index in terms of snow leopard probability of detection, the snow leopard probability of occupancy was not instead significantly affected by the considered covariates. So these results partially align with our initial assumption because, well, our initial hypothesis, because as expected, we did not observe a significant effect of both elevation and terrain gradients. While we also did not observe, contrary to our initial expectation, a significant effect of the density of riverine areas and the compound topographic index. For what concerns terrain readiness and elevation, as I said, as earlier stated, well, terrain readiness is a fundamental key habitat that typically influences the snow leopard habitat use. But as I said, in our study area, terrain was relatively homogeneous across different elevations. So this may have enabled the species to colonize the habitat across different elevations. But another aspect that should be taken into account is the presence of wolves in the area, even if likely at low densities, because according to another study realized by Professor Sandro Lovari and colleagues in Kyrgyzstan, the presence of the wolves significantly affects the snow leopard habitat use. In fact, typically wolves are present on the valley bottom, while snow leopards stay at higher elevation in order to avoid the risk of direct encounter with wolves, and consequently the risk of being killed by wolves. For what concerns instead the absence of a significant effect observed for the water resources, the data collected from our camera trap revealed that the snowfall that occurred during this season, despite mild, may have fulfilled the water requirement of the snow leopard, as reported in other studies. And additionally, the snow leopard may have taken advantage of the presence of water holes in the area in order to fulfill its water requirement, as reported in the study realized by Nasanbach and Tal in 2021 in the same area. As for the fox, we can say that despite the probability of detection was significantly and positively associated to the density of riverine areas, while significantly and negative associated to the elevation, again, we observe a significant and negative effect only for what concerns the terrain brightness in terms of red fox occupancy. So again, this result partially match with our initial expectation, as we observed no significant relationship with the elevation, a negative and significant relationship with the terrain brightness, while we did not observe a significant relationship between the density of riverine areas and the compound topographic index. For what concerns the elevation, our results are in contrast with other results obtained in other studies, where, as I said before, elevation exerts a key role because typically the dense snow cover, which are typically encountered at higher elevation, may limit the red fox movement and also the prey availability. And however, in our study areas, the mild snowfall, and especially the mild snowfall that we recorded during our sampling period, may have enabled the red fox to use habitat also at different elevations, so allowing the species also to colonize the mountain foothills and the higher elevation as well. Conversely, for what concerns the terrain brightness, as I said, rugged terrains are used as refuge areas by the red fox in the case of intense human hunting. However, because, again, hunting is forbidden in the Great Gobi, strictly protected area, rugged areas may have exerted a negative effect because, as reported in the study realized by Murdoch et al. In 2016, it typically hosts low prey density, so it is not a suitable habitat for the red fox. Sorry. For what concerns the absence of a significant effect of the density of riverine areas and soil moisture, again, this absence of a significant effect may be attributable to the use by the red fox of water hole in the areas, but also by the feeding behavior. So the species may have feed on other water-rich food items, such as insects, which, according to other studies realized on arid environment, may represent an additional resource of water in those cases in those environments in which water is scarce. For what concerns the conditional occupancy analysis, aimed to explore how the snow leopard presence or absence may have significantly or not affected the red fox occupancy, we observed that the red fox occupancy is significantly higher in the presence of the snow leopard, so matching with our initial facilitation hypothesis. This behavior, as I said before, was observed, comparing the red fox behavior with the presence of wolf and snow leopard. And for what concerns the snow leopard, a study realized in 2021, in which also Claudio is one of the co-authors, realized in the Mongolian Tolai. The authors in this work observed that on a yak carcasses, a female of about 250 kilograms that was killed by a snow leopard was also kleptoparasitized by other species such as raven and red fox. So indeed, the presence of carcasses may be beneficial for the red fox. And the presence, in turn, the presence of a dominant predator may be beneficial for the red fox in terms of feeding opportunities, as we said at the beginning. For what concerns the temporal interaction, despite the red fox tend to use the site used by the snow leopard and take on advantage of the carcasses left by the snow leopard, it's important to bear in mind that they try to modulate their activity pattern in order to avoid direct encounter with the snow leopard. In fact, the coefficient of overlap indicate moderate overlap between the temporal overlap between the snow leopard and the red fox. So partially aligning, at least for what concerns the temporal relationship with our initial assumption. In fact, feeding on carcasses left by large predators, in this case the snow leopard, may be risky for the red fox, Here I reported a study realized by Professor Gustav Samelion, Orion Johansson, and colleagues in 2022, in which they reported for the first time the presence of two carcasses of red fox, respectively in the Tibetan Plateau in 2011 and in the Mongolian Top Mountain in 2018, where these carcasses were found nearby a baral carcass for what concerns the Tibetan Plateau and a domestic goat for what concerns the Mongolian Top Mountains. Regarding instead the effect of the temporal effect of the presence of the snow leopard on its main prey, we observed a low temporal overlap between predator and prey, so in line with our initial avoidance hypothesis. However, we also have to consider that compared to the Siberian ibex and the argali sheep, which are typically reported as part of the diet of the snow leopard, the Asian wild ass and the Tolai hare, despite they may be prey, are typically outside from the preferred weight range of prey species for the snow leopard, which typically range between 36 to 76 kilograms. So it is also likely possible that both species, namely the Asian wild ass and the Tolai hare, may modulate their activity rhythm to avoid also other predators present in the area. And specifically for what concerns the Asian wild ass, they may modulate their activity to avoid the wolves, as it is reported in other studies that wild ass may fall prey of wolves. And the Tolai hare may modulate its activity to avoid the red fox, which is typically its main predator. So, to conclude, what emerged from this study is that according to the facilitation hypothesis, the presence of a large predator may be beneficial for the smaller one in terms of feeding opportunities, but as long as these smaller predators adopt smart behavioral strategies to avoid the risk of encounters with the dominant one. And instead, in line with the avoidance hypothesis, prey tended to adapt their pattern of activities to reduce the likelihood of encounters with predators in order to not become prey of them. However, as whatever study, basically our study presents some limitations, which are typically linked as a first to the period in which data were collected. So we realized and explored the spatio-temporal relationship between these species only in a single season. So we can define that the results we achieved are explanatory for that season. So extending the sampling period over more seasons would be beneficial to provide further insight. The low number of independent detection events obtained for certain species may have influenced the results achieved, especially in terms of temporal overlap. Because before I reported a study realized in 2018 by Lashley et al., in which it was reported that a number spanning from 15 to 30 independent detection may be adequate to describe the temporal relationship between species. But in order to obtain strong results, you need to have at least 100 independent detection events for each species. So extending the time period is furthermore important in order to obtain more detection events and again to more robustly describe the relationship between these species. And last, the sampling design was specifically tailored for the snow leopard, and so this may have affected the low number of detections obtained for other carnivore species present in the area. Additionally, the inclusion of diet analysis, especially for carnivores, may help consistently in describing the spatio-temporal relationship between the predator and prey communities, and especially to explore if the diet of a mesocarnivore, such as in this case the red fox, is in quotation marks similar to the one of the snow leopard in order to effectively assess and determine that they may take on advantage of the carcasses left by larger predators. So, to conclude, further studies based on what I said over an extended time period, which may enable the use also of other models, such as dynamic occupancy models, and including diet analysis, are strongly suggested in order to provide further and detailed insights. This is a quick list of the references which I have read cited across my presentation. Before ending my presentation, I would like to acknowledge the members of the Snow Leopard Network for inviting me to participate in this seminar, so thank you a lot for this opportunity. I also like to acknowledge the members of the Department of Biology at the National University of Mongolia for their precious help in data collection. And last but not least, I would like to acknowledge also all my colleagues, and especially Luciano Atteni, Sandro Lovari, Batok Nasambat, Samir Ratchig, Francisco Seacero Rador, Giovanni Bombieri, and especially Claudio Augugliaro, the founder of Wildlife Initiative, for giving me the opportunity to participate in this work. This is my last slide. Thank you very much for your attention, and if you have any question, I would be glad to respond. So, thank you very much.
Okay, so now after listening Marcello, please you can make any question directly here, or if you are shy, writing please in the chat. And as you see, we analyzed the occupancy probability, so related to the habitat use of snow leopard during the winter season, and also how it occurs with the mesocarnivores, such as the red fox, and we also analyzed separately the activity and the activity overlap of snow leopard and the prey. So if you have any question about the habitat use and about the activity overlap of snow leopard with prey, or even if you have some curiosity to extend to a broader area, at least in Mongolia, but based on this study, on what you listen now, we are ready to answer. So, okay, ready to answer here in the chat, please, any question? Okay, thanks, Ivan. We had data collected in the Great Gobi area still processing between 2022 to 2024. But I have to say that after this study, I realized that I prefer to the approach, for instance, the Snow Leopard Trust used in POST, where there is a multi-season, multi-year project, rather than have an instant frame of the some output, which can be the activity or the occupancy, which is with a single season, which is important, but obviously limited. So currently, thanks to the partnership of Snow Leopard Conservancy, we are implementing a multi-year project, long project, in the ecological pathway of Sutai and Myang Ugalzad in the Altai mountain, which is particularly important because that area is connecting the northern range of snow leopard and the southern one, which is from the Gobi to China, and then all the southern one. Thanks to Luciano Atteni, who worked on landscape connectivity model in that time, we spotted that area as a very, very important corridor in terms also of genetic flow, likely, for snow leopard. Not only in Mongolia, but from the northern range in the Altai to the southern one. So at the moment, we are working a lot on that to protecting the pathway, but also with over 50 cameras installed across the years in that area, we are now analyzing all the ecological aspect interaction with the other species and human. So I think with the answer to your question that this kind of approach is what we have to try to implement with the multi-season, if possible multi-years, because it's the way where you get really in touch with the local community and start building something that go really to give you a clear framework of what is going on. So, About the conflict, I think I can still answer it because I'm living in the territory. So sorry, Marcello, if you have something to add, you will free.
Don't worry, go on, no problem.
That goes right. Nevit, okay, about the conflict. Okay, coming back to what I was talking about. I realized that working with local community means stay with them and involve them. For instance, in that ecological corridor, now we are involving the local community on data collection through track survey, sign survey, giving them some form that every week they fill during their transit from their camp to the pasture area. So they feel involved and they are little compensated for that. Give us good data, a lot of good data, because we train them to do that. And somehow now I see their approach change slowly, of course. We already worked there since 2022. They started telling me that it's fine if they have some losses by carnivores because it's, how to say, a price to pay to nature. And also they understand that Snow Leopard wolf are not only something to shoot some enemy, but there is other people around that can be interested and watch them from some other side. We do a workshop every year, and then with them we discuss what is the issue. We try to help them to solve some issue, but involve them on their management by tracking them, talk what we found, their funding, and that's to say, in my opinion, helps a lot with detection. We have the first outputs where their attitude improved after we started to work in that. So my idea is always long-term project, and in terms of scientific research, like collecting data from camera trapping, but also involving local community. That's also the approach I suggest. I think it gave us some progress. Let's see if we miss some. Okay. Okay, Marcello, I think here there is Martin. You can answer to him, talk about water availability.
Okay. Yeah, well, that's an interesting question. Yeah, it would be interesting.
Can you repeat the question so the other can?
Oh yeah, sure. Sorry. Do you believe the water availability may be a more important predictor during summertime when I assume precipitation is more limited? How would it enter the interaction between snow leopard, mesopredators, and prey? So this is an interesting question, and for that reason, I mentioned that it would be nice to extend our study period across more seasons because, in fact, the spatial and temporal behavior in terms of species may be different according to season. Even because habitat is used differently, and also because resources are different. And considering that in the Great Gobi area, the water resources are scarce, and during summer it may be even more difficult to find these resources to exploit. And so additionally, this may significantly affect also the spatial and temporal behavior of predator, prey, and mesocarnivore communities. So it would be really nice to extend the time period for that reason.
Then there is Alessia asking about the scats collection and if it would be complicated to collect faces, okay, scats of snow leopard. Is there any pattern of marking the territory like the wolf? Collecting scats depend. In Mongolia can be quite complicated because the wind is very strong. For instance, in the Gobi is really hard. Sometimes you go don't find any track. Even no one collected them, but the wind and the weather very dry. Sometimes the snow destroy all proof. In that time, maybe a bit more simple, but not so simple. Anyway, it's possible. I don't know. The degradation can be, depending from the period, can be quite fast anyway, especially for mechanic solicitation, like with wind, exactly, rocks, sand is going to be really quite hard. About the pattern of on marking, like marking behavior, no, I don't think is so specific like a wolf. There is a kind of territoriality for male, but it's not so strict. Generally, male share the territory with the female, which also mark anyway the territory. And then is thank you very much. Tobias. Okay, let's see. Ask when you showed the activity pattern was not together with the prey species. You mentioned at one point that the prey species may have also reacted to predator. Understood right? I thought it would have been very interesting to see multiple predators, Snow Leopard plus wolf together, with a single prey species. Okay, also it was not the scope of your study. I think your data may allow for that, but probably I missed along the way. My sound, unfortunately, not very good. So, can you answer to this question, Marcello? Is that
Yeah, sure.
okay?
Well, sorry, I apologize because maybe I was not sufficiently clear, but thank you very much for your question. Unfortunately, the few number of detections we obtained for wolves, because we obtained 3 or 4 wolves independent detection, would have not allowed to explore in detail that kind of relationship because, well, as I said, the sampling design was specifically tailored for the snow leopard in order so basically to explore and analyze this question in detail, which is super interesting. It would be necessary to realize a general, we can say, sampling design, not specifically tailored toward a single species. So maybe obtaining also other detection for wolves would have enabled us to explore in detail this aspect. But as I said, the few number of detection we had did not allow us to say anything, basically. So we speculated the result we obtained based on what we observed and based on what is known from the literature, but from our data we cannot say nothing more in detail.
Okay, I answered to Paulina, and then Raggi reminded me the question of Navid. Navid asked if we find a solution to decrease the conflict in the area, while Paulina asked if there are any cases of snow leopard poaching in the region. So before I turn to another area, but in Mongolia, because in the Great Gobi strictly protected area, we are talking about almost 50 square kilometer, 50,000 square kilometer, which is really a huge area, where basically there is no people living there. There is only customs with the militaries, soldiers, and a couple of them have some livestock. So sometimes they don't live in the custom, but in their yurt, ger, the Mongolian tent, nearby the custom anyway. And the only case of conflict is basically with them, more or less. And actually, we have also a video. We got a video from one of them with a colored snow leopard. It was the only one color in that time, eating a goat. And these elder soldiers with the car that try to put music at high volume with the light, whatever. The snow leopard just don't care, keep eating. Because they are quite stubborn once they're on the prey. But it's difficult to talk about a true conflict because except these elders that in the truth they are soldiers mostly, there is no people living there. So in this case, we have actually, except some exceptional case, we have a side where we can understand the behavior of these carnivores in the human absence, substantially, because it's not relevant to the human presence anyway, not much affecting their behavior. In fact, you find a pack of wolf that you don't find even in a forest in Mongolia, for instance, because they feel safe. So in that times, this study site is a good laboratory to understand how animals live without humans. For the conflict, as I explained, we extend our work outside this area. There is a quite high conflict, especially in that area where we are working in that time. And as I told you, the involvement of local community is obviously a most important thing. But the point is how to involve the local community. And I have to say, in that way, involving data collection, giving a little compensation, but to make them feel as a part of the project is surely a way to reduce their bad attitude toward the carnivores and collaborate on that. Yeah. Okay. Yes, we basically have a community. The contest we are experiencing in Mongolia with the Snow Leopard Conservancy project is that we have two big massive. One is called Sutai, and also Irbis Mongolia. Another one is called Miango Gazad. In the middle, there is stepping stones, Marcello has been there, where even very low elevation from the plateau, like 50 meters, Snow leopard live constantly in these little stepping stones, basically, talking about 10 square kilometer, 20 square kilometer, not big one, even less than that. And constantly, the snow leopard live there or move across. So the people live just under the stepping stones with their tent. So the conflict is really, really high. When we arrived, they had a really bad attitude about towards snow leopard. So a prostitute family lives in this area and moving between the mountain valleys and the stepping stones, depending from the season. We distributed some form that of one single sheet where they just have to record the tracks they see from wolf or snow leopard, if there is some carcass or wild or domestic ungulates, and the date and the time. Every week they have to fill this form, and then we have a focal point, which is the local ranger collecting the camera trap data, the 54 camera trap data, that collect every once per month this data, and then we have a way to send them to Ulaanbaatar, and basically we copy to in electronic file to analyze the data. It's a constant work we do, and obviously they pay a little compensate, because after all, if I go to the field, I have to spend money to pay the trip, pay the food, pay the cost of the petrol. So if that money are just spent for local people that help anyway, is very, I think, is a good idea. And I have to say that every time I go, they just are happy to share anything they saw in all the last period. Tell me any news, any animal they see, what is their opinion. Everything totally changed from the beginning, I have to say. But as I often say, stay on the sides. It's really important, because once you go, a niche is open, and maybe hunters, or maybe mining, or maybe whatever will insert in your place. After a few months, probably they will forget about it. So as long as we stay, and better is it to keep them on our and the Snow Leopard side. That's what I think. So that's what we're doing at the moment. There, I think it's a good model, can be exported. And then, folks, this can do. Okay, Marcello, can you read Sandro comment?
Sure. Now that's an interesting point. The professor said about the relationship between fox scavenging from kills of a superior predator. Most likely it's a matter of density of soup, predator and other scavengers too. Scavenging is a high-risk, high-gain method. When carcasses disappear quickly, scavenging may turn into high risk, low gain. Then the inferior predator may decrease scavenging. Yes, it's right. Yes, that could be possible. And for that reason, I was thinking while reading the question that it would be also interesting to explore the density of prey typically used by mesopredators, because I would like to see if in the presence of low prey density for mesopredators, feeding on carcasses left by larger predators, even if low, may become an extremely high risk but unnecessary gain strategy in order to survive. So it would be nice to, I think, broaden this aspect to obtain also other information in detail, despite all the difficulties in realizing this kind of analysis, which requires a considerably higher something effort.
Okay, again, Flavia asked if we plan to expand our work more specifically about the relationship, interaction between Snow Leopard and wolf. Actually, yes, because as a non-profit organization that work on research and conservation, we are very interested in conservation, which means in the place where we are working, Snow leopard rise a very high conflict because, as I told you, live next to human. But generally, at least in Mongolia, Snow leopard pay for the conflict human has with wolf. Very often happened to me, like in the Altai Mountain, Tamanbog National Park in Mongolia, for instance, which is the area bordering China, Russia, and almost Kazakhstan. There I saw many people that doesn't care much about Snow leopard, like indifferent, but they care much about the wolf. I use non-selective, like a leg jaw trap, which can catch also Snow leopard, of course, not only wolf, non-selective trap. So anyway, somehow the wolf and the bad attitude human had toward wolf affect directly or indirectly the Snow leopard. So we take into account the wolf also for conservation of Snow leopard, and actually just now in a review is a work with we prepared with Marcello and the Snow leopard conservancy team mainly about the work we did in Bayanluki province, which is the westernmost province of Mongolia, where we implement a project before than the one I described, where actually that is about human dimension, but also in terms of ecology, we think that work on Snow leopard and wolf interaction will be crucial this year, and even integrating our ecological outputs from our analysis with the human dimension can be, how to say, a new frontiers, let's say, of the study that we will try to conduct. Yeah, about the scats, I answered to Alessio that collecting them in Mongolia is not that easy because there is quite a fast degradation due to meteorological condition, but also very strong wind that move stones, move the scats out from the marking sites, and science then often really is hard to find, and also in terms of the pattern marking territory is a bit different than wolf, and both sex mark the territory. We find female and male independently in the marking sites, and yeah, I think that if there is more specific question, I can answer. Anyway, thanks for the several questions we received. It was a pleasure to discuss about our project. And for sure, as a lucky promise, some future webinar will come with our future work. So we'll discuss it.
Yes,
you will have some follow-up.
Yes, we will invite you both back. That was very interesting. Thank you both so much. Lots of information. It was really great. And I think we had a lot of questions. Thank you so much, Claudio and Marcello.
Thanks, Nike. Thanks everyone for participating. And then see you next time. So
We hope to see you all soon.
yeah. Okay.
Thank you so much.
Thank you. Bye. Bye.
Thank you. Bye. Have a nice day.